In question number 109, it has been asked to us that the major product formed in the following reaction we have to find out. So over here, this is basically, we will say, hydration of alkyne, okay, and we are using basically mercury over here, okay. So basically over here what happens is the C triple bond C pH, one can think there is a addition of, so in presence of Hg2 plus, one can think there is addition of water across the double bond, okay. So the best way of doing this is, even though this is not the correct mechanism, is just to add OH and H across this alkyne bond and then think tautomerism. So that way if we do, the enol converts to the following ketotautomer, and then if we compare, we will say our answer over here is going to be C. Next problem, major product formed in the reaction of N N-dimethylaniline in concentrated H2SO4 HNO3. So this is acidic medium, and we are basically using N N-dimethylaniline, which is obviously this one. So in a highly acidic medium, okay, protonation of the plus M group, this is basically a plus M group, occurs, and this becomes NMe2H plus, and so this is now a minus I group, and it is a meta director, okay. It is a meta director for electrophiles. So if you are using HNO3 along with H2SO4, from this the electrophile formed obviously is NO2 plus, and that should enter the meta position as I have said, and hence the product that one should expect from this reaction is going to have the structure as follows. So out here we will write A should be our solution. Next, the major product formed in the following reaction we have to say. So basically OTS is a very good leaving group, and we have been given OET. So these are conditions for elimination reaction. This will be taken up by the proton that will go here. So via a concerted mechanism, we can now say that the two Me will be on the same side, the H will be behind, and the phenyl will be like that behind. So we will say our product over here is going to be D. Okay, next we have been given 112. So this is basically condition under which Cna substitution should take place. Okay, so over here what will happen, the hydrogen over here is sufficiently acidic for a strong base like NH2 to take it up, and so that means over here a minus sign is formed. Now this comes here and that goes there, and one can think the formation of a 2,3 benzene over here. Okay, now the benzene, after it is formed via elimination of Br, we'll add the NH2 or NH3 from the medium. Now addition can take place here or it can take place here. So we can expect two products. So now we have to think about the stability of the product. That is the anion formed over here. Now carbon ions are destabilized by plus I groups. So we can see that we have a CH3 over here. And this is showing plus I effect. So this will destabilize second one more than compared to 1. So 1 is major and this is minor. And hence after it takes up the proton from the medium, we will say product number 1 or coming from 1 will be the major product over here. So that way if you think, this is the major product and that is the minor product. So we will say answer D is the correct option. Next we have been given which of the following reactions is not an example of a ipso-substitution. Okay. So over here ipso-substitution means there is a leaving group and something is replacing it. So over here in this condition we can think this is a basic medium and our leaving group over here is chlorine. So this is getting or undergoing aromatic nucleophilic substitution reaction. Okay. And correspondingly the Cl is being replaced and the OH is formed. Here also there is a lone pair. SO2PH is a good leaving group. There also it is replacing the SO2PH group. So this is also a ipso and that is also a ipso. However, over here it is undergoing under the influence of NH2. This will be taken up. So there will be a formation of a negative charge here. Br will be formed here. This is OMe and that will go there. This will go out. And subsequently we will have the formation of a benzene again, which is 2,3. Alright, and then that would lead to the formation of the product over here by the attack of NH2 and subsequent protonation. So this is involving a benzene mechanism and not ipso. So this should be our answer for this question. Again, as we can see, if one nitro group can assist the aromatic nucleophilic addition elimination reaction, 3 nitro groups will help the easier replacement of chlorine over here via the attack of OH ion at this place. So A, B, C are D are A, B and D are ipso substitution and C is your not ipso substitution. Next, we have been given the question, the products formed by the reaction of toluene with chlorine in presence of sunlight. So what we will say is in presence of sunlight and we have chlorine. So there is a formation of Cl radical which will take up the H via a free radical mechanism. Okay, here this unit of the toluene is behaving like an allyl group Okay, so over here we will say that this leads to the formation of a allyl or a allyl type radical within the benzyl. So this is like CH2 dot radical. Now this unit altogether is a benzyl radical which can undergo resonance stability, which we are not showing over here. So there is another Cl dot within the medium, and that can undergo reaction with this to give you the formation of benzyl chloride. And D should be our answer over here. In the next question, we have been asked what should be the major product in this reaction. So over here, the product basically this leads to the formation of NHCH3NO. This intermediate is formed. However, in the presence of HCl, okay, the NO is released as a electrophile, and subsequently what we will say is, so this is plus and this is Cl minus. Subsequently, it will be the ortho position that will be attacked by the NO plus, and the product will be formed is obviously going to be B. Okay, next.